Hi there, in this video we're going to work on solving a linear system of equations using a matrix equation. So what is a matrix equation? So we can turn a system into a matrix equation, something of the form a matrix times a matrix X equals some other matrix B. And so the way we can turn this, so A will be the matrix consisting of the coefficients of the x's and the coefficients of the y's. So 3 and 7 are the coefficients of the x's. The coefficients of the y's are 4 and 9. And then we multiply by the matrix X. The matrix X is usually the variable matrix. So this is X and Y. So it's a 2 by 1. So notice now if I multiply 3 times X plus 4Y gives us the first equation, part of the equation, the side that's on the left. And then 7x plus 9y gives us the left side of the bottom equation. And so this is going to equal matrix B is what's on the other side of the equals, on the right side, so 10 and 20. So now putting this together, we will get 3x plus 4y equals 10. So that gives us the first equation. So how do we solve? Just like you would before with any equation, you want to isolate the x. But remember, this is a matrix, so I can't say divide by x. So we have to multiply by the inverse. So what we will do to isolate x, multiply both sides. And I'm going to say it on the right. Sorry, we will multiply both sides on the left by A inverse. Y on the left, so what does that mean? So that means I'm going to say A inverse times A x equals, multiplying A inverse on the left, will be A inverse times B. And A times A inverse gives us the identity matrix. So in this case, it's a 2 by 2, so it'll be I2 times x, which is a 2 by 1, equals A inverse B. And so this will be the answer. And so notice that if I was to do on the right, remember multiplication of matrices is not necessarily commutative, so I can't, so if I had back with real numbers, if we were working with real numbers, if I had 1/2 x equals 4, and I want to get rid of the 1/2, we will say, oh, multiply both sides by 2. And then oftentimes some people, what might do is, you will do this, multiply, it doesn't matter on which side. Sometimes we don't multiply it on the left because it might be hard to squeeze it in there. So we multiply it on the right. But that's because in the real numbers, multiplication is commutative, right? So 2 times 1/2, I'll get x equals 4 times 2 is 8. And so 4 times 2 is 8, but also 2 times 4 is 8. So multiplication in the real numbers is commutative, but for matrices, multiplication of matrices is not commutative. And so we can't assume that it will be. So that's why whatever you do, we're going to multiply on the left here, right? Because we want A inverse to multiply A. If I can't really multiply A inverse on the right because then I will be multiplying it by X and my A wouldn't go away. Okay, so now I know that this matrix, so this is my A times X is equal to B. And based on this equation, we just saw that X, the matrix X is equal to A inverse B. So the task is find A inverse. So we can perform this multiplication. A is a 2 by 2 matrix, so we can use the shortcut formula that A inverse is 1 over AD minus BC times the matrix where you switch the A and D. So D comes up here, and A goes on the bottom, and then B and C, we just change the signs. So minus B minus C. So in our case, let me write them out. A is 3, B is 4, C is 7, and D is 9. So this becomes 1 over AD, so 3 times 9, which is 27, minus BC, which is 4 times 7, which is 28, times the matrix. I'm going to have 9, -4, -7, and 3. 27 minus 28 is -1, so I really just have -1 times this matrix. And so change the signs. So I get -9, +4, 7, and -3. So this is A inverse. Now that I have that, I can say back from that x up there, so x is equal to A inverse, which we just found, -9, 4, 7, -3, times B. B is 10, 20. And can we do this product? Always check. This is A inverse is a 2 by 2 matrix, and B is a 2 by 1 matrix. So those match, so that means yes, we can do it. The resultant product is going to be a 2 by 1 matrix, because it makes sense because X is a 2 by 1 matrix. So let's multiply it out. So again, we do the first row times the whole column. So -9 times 10, so that's -90 plus 4 times 20, which is 80. So my X, the first entry is -10. Now for the second one, so 7 times 10 is 70, plus -3 times 20, -60. 70 minus 60 is +10. So that means that is what we think our answer is. So therefore the matrix X was XY is equal to -10, 10. Right, so this tells us that X is equal to -10 and Y is equal to 10. So that will be the solution to the system. And of course you should always check it. So pick one of the equations, or you can plug it into both actually to be more accurate. So 3x plus 4y equals 10 is the first equation. So let's check it. If x is -10 and y is 10, so plugging in this point in here to check it, I'm going to have 3 times -10 plus 4 times 10. Does that equal 10? -30 plus 40 is 10, yes. And then when you check -10 and 10 in the second one, so 70, -70 plus 90 is 20, so that does check. Cool, so this is how we solve a system of equations using matrix equations. When you have two equations and two variables. So what happens when you have 3 equations and 3 variables? So let's go to the next problem. So this one, solve the linear system of equations using a matrix equation, but now we have 3 equations and 3 variables. So we're going to do the exact same thing. So we're going to write it as a matrix equation. So we're going to have AX equals B, which again multiply on the left by A inverse. So I'm going to have A inverse times AX equals A inverse times B. And we do it on the left. So which tells me that X is A inverse B. Can we do this multiplication? A in this case is going to be a 3 by 3 matrix. So A inverse will be a 3 by 3. B is a 3 rows in just 1 column. So it's a 3 by 1. So can we do this product? Those match, so yes. And the resulting product will be a 3 by 1 matrix, which is what we want. So let's go ahead and write it as a matrix. So I'm going to have A is 2, -1, 1. So those are the coefficients of X. Then the coefficients of Y, 4, 1, 4. And then the coefficients of Z. So 1, negative 1, 0 times x. The matrix X is the matrix XYZ equals B. So the matrix B is what's on the right side of the equations on the system. So 7, 0, and minus 2. My 7 was looking a little funky. Okay, so now we know X, so XYZ has to be a 3 by 1 matrix, and which is what we are going to get here. So X is A inverse B. So our task is find A inverse. And for a 3 by 3, it's not as nice to use that shortcut. So we have to do it write it in reduced row echelon form with the identity matrix on one side. So to find A inverse, write your augmented matrix. I'm going to have 2, 4, 1, negative 1, 1, minus 1, 1, 4, 0. That's A. And then we're going to write the identity matrix, 3 by 3 matrix on the other side. And we're going to perform row operations to try to get the identity on the left, and then whatever we end up with on the right will be A inverse. So let's see. The first goal is to get a 1 on that first row, first column entry. And there's different ways with this one that we could do. We could add row 2 to row 1 to get a 1 there. We could also I already have a 1 in row 3, so I'm gonna do the cheap and easy way and just exchange those rows. So I'm gonna exchange row 3 for row 1. So exchanging these rows, we're gonna get, so row 3 is gonna change with row 1. So my new row 1 is 1, 4, 0, 0, 0, 1. Row 2 stays the same, we didn't do anything there, so negative 1, 1, negative 1, 0, 1, 0. And now row 3, the new row 3 becomes what was row 1. So 2, 4, 1, and 1, 0, 0. So now that we have the 1 where we want it, our next goal is to get zeros underneath it. Every time you get a 1 in the place that you want it, you want to make sure that you get zeros in the other rows of that same column. So here I want to get a 0 in row 2 and in row 3. So how do I do that? Well, I'm going to that's already a negative 1, so I'm going to add row 1 to row 2. So I'm going to say row 2 plus row 1 gives us the new row 1. So that will be, so row 1 is staying the same. So 1, 4, 0, 0, 0, 1. I'm using row 1 to change the other rows, but row 1 itself does not change. So I wrote this in the wrong place. It's actually row 1 plus row 2 becomes the new row 2. So when I add row 1 and row 2, I get 0, 5, negative 1, 0 plus negative 1 stays negative 1, 0 plus 0 is 0, 0 plus 1 is 1, and 1 plus 0 is 1. And on the bottom for the new row 3, I need to get rid of that 2. That's a positive 2, so I'm going to multiply row 1 by a negative 2, the whole row by a negative 2, and add it to the whole row 3. So it'll be minus 2r3 plus, minus 2r1 plus r3 gives us the new row 3. So minus 2 plus 2 is 0, minus 8 plus 4 is negative 4, 0 plus 1 is 1, and then those are zeros, which is nice. So the bottom one stayed the same, so it'll be 1, 0, and now I'm doing this one, so it'll be minus 2 plus 0 is minus 2. Okay, so now we have 1 in the first row, first column, and zeros on the other column, the same column over here. So the other rows, same column, are zeros. Now I want to get on my second row, second column, where that 5 is, we want to get a 1 there. So I could divide everything by 5, right? Multiply this row by 1/5, but I'm going to introduce fractions. So what else can I do without having to introduce fractions? Sometimes that's our only option, but if we have other options, let's exercise those other options. So notice that row 3 here is a -4. 5 minus 4 is 1. So I can essentially add row 3 to row 2 to get a 1 there. So that's what we're going to do. So row 3 plus row 2 is going to give us the new row 2, which means row 1 and row 3 are going to stay the same. So I'm going to have 1, 4, 0, 0, 0, 1, and row 3 are staying the same. So 0, -4, 1, and 1, 0, -2. So those are staying the same, and we're changing row 2 by adding row 3 to it. So 0 plus 0 is 0. -4 plus 5 is 1. 1 plus -1 is 0. And then 1 plus 0 is 1. 0 plus 1 is 1. -2 plus 1 is -1. And so this is my new row 2. So now that we have a 1 in the second row, second column, what is our next goal? Now we want to make sure that we get zeros on that same column, the other rows that don't have a 1. So I got a 1 in the second row, so I got to make row 1 and row 3 zeros. So what we're going to do then is I'm going to move to row 1. So I'm going to multiply row 2 by -4 and add it to row 1. So let's try that. So when I do this, I'm using row 2 to change the other one. So row 2 is going to stay the same. So 0, 1, 0, and 1, 1, -1. So this one, row 2 stays the same. And for the first row, we said -4 row 2 plus row 1 gives us the new row 1. So there's a 0 there. So this one isn't affected. -4 plus 4 is 0. -4 times 0 doesn't change it. So I get a 0 there. And then -4 plus 0 is -4. -4 plus 0 is -4 again. -4 times a -1 is 4, plus 1 is 5. And for row 3, we want to get rid of this -4. So I'm going to multiply row 2 by a +4 and then add it to row 3. So 4 row 2 plus row 3 gives us the new row 3. So I'm going to have that's a 0. So +4 minus 4 is 0. 4 times 0 is 0, plus 1 stays 1. 4 plus 1 is 5. I multiply by a +4. 4 plus 0 is 4. Multiply by a +4, so I get -4 minus 2 is -6. And notice that we got the identity matrix already here. We have 1s in the places where we need it around the main diagonals and 0s everything else. So this is the identity matrix 3 by 3, and that means that this must be A inverse. So we found our A inverse is that nice matrix, -4, 5, 1, 1, -1, and 5, 4, 6. -6, sorry. So now let's go back and remember that we were solving for x. So x is A inverse times B, and B is 7, 0, -2. So let's go and find that product. That was the whole point of us finding A inverse. So now the matrix X is equal to A inverse times B. So that means that I'm going to have A inverse -4, 5, 1, 1, -1, 5, 4, 6 times the matrix B, which we said was 7, 0, negative 2. Can we do this product? We should be able to, right? This is a 3 by 3 multiplied by a 3 by 1. So yes, those match up, so we are able to do it. And the resultant product is going to be a 3 by 1 matrix, the outside. So let's multiply it out. So we go the whole row by the whole column. So negative 4 times 7, that's negative 28. Negative 4 times 0 is 0. 5 times negative 2 is negative 10. So this is going to be negative 38 for the first entry. Now the second one. So 1 times 7 is 7, plus 1 times 0 is 0, plus negative 1 times 0. Negative 1 times negative 2, which is positive 2. So 7 plus 2 is 9. And then 5 times 7 is 35, plus 0. And then negative 6, I keep forgetting that's a negative 6. Negative 6 times a negative 2 is positive 12. So 35 plus 12 is 47. So that will be our answer. So x, y, so the matrix x, x, y, z is equal to negative 38, 9, 47, which means that this is the solution to the system. So the solution is the point negative 38, 9, 47, which is the XYZ solution. And of course, whenever you have time, you should check your answer. So the original system, so we have x plus 4y equals negative 2. I'm going to check it in the second one and the third. So the second one is negative x plus y minus z equals 0. So negative x plus y minus z equals 0. So does that check for this particular point? So I'm going to have negative and negative 38, so positive 38 plus 9 minus 47. Does that equal 0? 38 plus 9, so that is 47 minus 47 is in fact 0. Yay! The third equation was x plus 4y equals negative 2. So if you check the point into this equation, x is negative 38, so negative 38 plus 4 times y is 9. Does that equal negative 2? Yes, 4 times 9 is 36, so negative 8 plus 36 is in fact negative 2. So the only one to check is the first one, but it will work as well. And that's how you solve a system of equations with 3 variables by using a matrix equation.